Thanks everyone for joining. Today is day 12. We are going to discuss about OMP, the remaining portion, and then we have to perform on a small lab related to OMP. I'll show that how you can go and create the connected routes inside any VEdge, and it will go reach to VSmart, and then VSmart will work as a route reflector. It will reflect that particular route to different VEdges or branches. So that lab we are going to perform today. Apart from that, we are going to discuss about edge devices provisioning. In that, you'll come to know that the difference between PNP and ZTP, sometimes you are hearing PNP, sometimes you are hearing ZTP. What are the differences in between that? We are going to check all those information. So let's start with OMP first, and then I will go and check the ZTP. All right. So what we have discussed in previous section, we have discussed about that what is OMP, what are the attributes of OMP. First of all, routes inside OMP, then what attributes we have inside OMP, then how OMP is doing best path selection or loop avoidance. Now, next topic. Now we have a small topics, important topics related to OMP. We are going to discuss all those one by one. Maybe you have heard about graceful restart for OMP. So what does it mean by graceful restart? It means, oops, it means that by any chance, if your control plane will get restarted or maybe it is unavailable, then what will happen with the data plane devices? What the data plane devices will do? So answer for this is this, that data plane devices will go and continue forward the data as per the last known information they got from the control plane. And how long they will do that? They will do that by default till 12 hours. So what does it mean? We know that these edge devices, they are sending their prefixes or they are sending their OMP route details to VSmart. VSmart, if inside VSmart you are not configuring any type of policy or routing policy or control policy, then by default it will reflect all the prefixes to other devices. Now what is happening that these devices will show you a status CIR, that is, it is a route which is installed inside the routing table. I for installed, right? CIR status will be installed. That means that inside the routing table of all these devices, you can see that the route is there received from different VSmart and it is installed. Now suppose due to any reason if VSmart is gone, still whatever installed route they have inside their memory or inside their routing entry or routing table, they will still continue forward their data according to that for last 12 hours. Now again, this is default value, but I think this is from you can see here in the bottom, 1 second to 7 days. So from 1 second till 7 days, you can tune the timer. Now suppose somehow within 12 hours you are recovering your control plane. So once control plane will get recovered, means now it is up and running, some issue with the VM, some memory issue inside the VM, some bug is there, it got rebooted within 12 hours, somehow again it will come back online. Then what will happen? Then this VSmart will send one type of marker, it is termed as EOR, end of rib. That means it will tell, now I'm learning all the routes from last 5 minutes, and now I have the updated routes from all the location and all the branches. You should use my new routing update. I'm sending you end of route is some sort of marking that whatever routes you have, you go and refresh your routing table with my new update. So it will send update, and all those edge devices will go and update their routing table as per the information it will get from the VSmart. Okay, so this is termed as a graceful restart inside OMP. You can go and configure it. You can go to OMP. You can use this command timers graceful restart, and you can give the timer from 1 second up to 7 days, 604,800 seconds. Okay. In the same notes, you'll find that graceful restart graceful restart configuration is there, but in the same notes you'll find after maybe 5 slides you have to go next, and you can see that EOR timers are there. The default is 5 minute or 300 seconds. So logic behind this is that VSmart, once it will come back online, it will start learning all the prefixes for 5 minutes, and then it will send the update to all the edge devices. Okay, with EOR, it will tell that I have learned this, and now you can update your CPU, or you can update your routing table with this. Here also you can see that this is also a configurable command or configurable item that range from 1 second up to 1 hour. So it can learn just for 1 second and then it will start updating, or it can go and learn up to 60 minutes and then it will go and update. Okay, so these are the easy things we have inside OMP. Actually, OMP itself is very much straightforward because for sake of simplicity, you can understand that your control plane is understanding only one protocol, that is OMP. Although we can send different type of routes uh, to OMP or inside OMP that will reach to VSmart. So what does it mean? It means that suppose that you have one branch, and in this branch you may have Ospf, you may have BGP to any service side VPN, maybe VPN 10, 20, etc. Now think like this, all these routes, they are local, correct? Local or internal to this particular V edge or C edge. Now by any chance, if you want to send these routes to VSmart, you can do it. What you have to do, you have to go inside overlay management protocol OMP, and then you need to advertise either OSPF or connected or BGP, etc. Now VSmart will learn these routes with these attributes. So it will know that what is the origin, who is the originator. All these informations VSmart knows while sending these updates to other devices also via OMP. So now what will happen, that this particular device, suppose this is VH2, when he receive the routes, he will know only that I'm getting all those routes via OMP. But if you go inside this OMP and that particular, suppose 1110/25, he is learning, VH is learning via OMP, which is advertised under OSPF. So from OSPF, going inside OMP, now VSmart, uh, because since he is route reflector, he is sending that route to other side, V edge router. Now, if you go and check the details of this particular route and this particular prefix that I'm going to show you today in the lab, you will see that OMP having attributes that it knows that who is what is the origin, which type of routing protocol is it. Okay, all those information it has. And remember, OMP has one more attribute, T-lock. So OMP knows that what is the next hop, what is the transport locator, which particular ISP color system IP I am getting these routes. So in a whole, you will see that OMP knows almost everything related to routing and routing attributes, routing updates. Okay, so that is one way. Now think in the reverse direction. Suppose uh, your LAN side network or your um, edge devices, right? They want OMP routes. And since here you are running OSPF and maybe here you have some other router, here you may have some other LAN or WAN network internally behind this, or maybe any type of third party, third party business acquisition, or maybe third party, third company business you are acquiring, and then they are running some other protocol, etc. Maybe any type of use case. So the use case is this, that suppose you want to send the OMP updates to this side. Again, what you can do, you can go to OSPF and then you can redistribute OMP. So in this way, you'll find that you are sending routes from OSPF to OMP, and then you are sending the routes from OMP to OSPF. This two-way type of redistribution can happen. While you are doing the redistribution, you can go and use a tag as well. Whenever we are doing redistribution, it is a best practice to use tags because it will provide you loop prevention. Okay, so those
Ratnesh,
uh, yeah.
can you explain the tag part or like just read the example?
Tag is not new concept. Whenever we are doing route redistribution in both directions, the concept behind this tag is this, that you don't want those network that you are sending. So suppose I am sending some route with tag value 10, and same tag, if this particular router will get tag 10, obviously tag 10 means it is tagged with some specific routes, maybe X1 and X2. So that means when you are receiving the tag, that means you are assuming that you are receiving X1 and X2 routes. That means there will be L3 routing loop, right? So what we are doing, that whenever in normal route map, we are giving one statement, deny um, 5, and in that we are making one statement, a match tag 10, and then you are giving all permit statement, permit 10, 20, 30, whatever. That means that first of all, if you are seeing this particular tag, you are dropping it. This is in one direction. In other direction also, you can do the same thing, right?
Mm.
You can watch this recording. If you do some lab, you'll understand this. So if you are sending your update with tag 10, okay, then you don't want same tag to come enter in your routing table. Likewise, if someone is sending you some update with tag 20, they don't want that you send the routes or they receive the routes with tag 20, because again the routing loop is there. Whatever you are sending as a routing, you don't want to get that same thing, because again you will receive, you will learn, again you will send, because routing tables are like that only. We are
It is
learning and
same like the AS path, right? Means whatever the route is advertising, it is checking the update in the AS path. If it is the same AS path receiving the route, it will drop the packet. So is it
yeah,
like
means
same?
um AS path is also doing loop prevention.
Right,
So
right, right.
yeah, loop prevention. Almost, we can't say same, but
Because you're saying that
idea is
if
same.
the tag 10
Yeah,
is sending the packet, whatever the packet is sending, it is tagging 10.
yeah,
And if the other side, if it is receiving the tag 10 packet, then it will think that I'm receiving the same packet and it will drop the packet, right?
yeah,
This is
yes,
the loop prevention mechanism you were saying.
yeah.
Yeah, this is
So
basically normal routing tagging. This
routing
one.
tag, yes, normal routing. So we are providing a statement, and AS is also there to do this loop prevention. That's correct. But AS is actually, um, within one AS you may have 100 or maybe 1,000 routers, right? And this is just for one routing update or a group of routing update with one tag value. In this, even for two routers, you can go and create this tag. AS, you can understand, this is like, big autonomous system, and then it is going to next big autonomous system and next autonomous system, like that.
Correct.
Okay, so, but yeah, means
So
both are
here,
there.
whatever the packet, it is grouping of that packet, and after that, it is tagging with any number, right? To send the update towards outside.
Yeah, means that's the concept of tag. So you can
Okay.
tag it, whatever you are sending, you're not expecting to come
Mhm.
those routing again to you, like, then there will be loop,
Mhm. And
right?
one more question. Here.
Yes.
So suppose that there is a two branch site, and in one branch site, if you are sending the traffic from the VPN 10, just for the example, VPN
Mm-hmm.
10 traffic is going to advertise towards the OMP, reaching to B Smart, and from B Smart again, it is the reflecting to the different branch office. So if the other branch office is having the different this DPN number means DPN 20. So it will create some problem or it will receive that packet.
It will never
Maybe the
receive
other
that packet.
it will never receive. Means both branch would be having the same VPN 10, right? Then it
Yeah,
will receive.
yeah.
Okay,
And if you
okay.
want to do inter VPN routing, this
Mm-hmm.
term is called route leak inside SD-WAN. So we have to go and create some sort of policy, and we have lab for this. But today, what I'm going to do, that within same VPN, I will create one route, and you will see that will be reflected to other branches, but within same VPN. If we want to see that in other VPN, we have to create some policy.
Okay. If it will be leaking, then it will be received, right?
Yep.
Okay,
So
okay.
let's quickly do this thing. Let me quickly go connect to the VPN, and let me show you this particular lab, then we'll move forward. Let me pause the recording. All right, let's go and see this. So I'm going to show you one lab. What I'm going to do is that I'll go and create one network inside one of the data center, and once we go and create that network, you'll find that it will be reflected to all other branches, and obviously within same VPN. That particular network you will not see inside other VPNs. So suppose if I go and create a network inside VPN 10, you can see only inside VPN 10. If I go and create inside VPN 20, the other branches you will go and see only inside VPN 20. In case that if you want to do um, route leaking, we'll see that in upcoming section when we'll study about control policies. All right, let me quickly log into the vManage, and what I will do that I'll go and detach one of the edge device, so I can go and do all this configuration via CLI. Otherwise, if you want to do it, you can create the um, loopback. I'm going to create one loopback, so you can go and create the loopback via template as well, but you need to attach the template inside VPN 10. So both way you can do. There is no problem doing on any other way. Let's quickly go and detach the template for DC edge 1. and then I will log in via the CLI. So we can go to the menu, configuration, templates, and for DC I can go and click here. I just wanted to detach devices, and DC1 VH, click detach. Okay, so while this template is detaching, I
Ratnesh,
can,
I'm seeing that there is a two VS devices in the DC, right?
yeah,
Yeah, so you detached both the VS devices,
one,
only one, huh?
yeah.
Okay. Could you please explain through the diagram, means how this VH, DC VH is connecting through this VS devices, means remote site, branch site?
Okay, why not? It is there in slide as well. You can see,
This is the lab topology, right?
yeah, this portion we have.
Okay.
Very straightforward. You have LAN interfaces, VPN 1020, where we have all these ADs, workstation, and firewalls, etc. Then you can see CE router, Internet CE, going towards PE routers inside the cloud, and then one cloud with different AS, I think AS 100 or something. You'll see that we have all the controllers inside that. Then we have internet
So
transport here
this
also.
DC side router that is connecting from the VS, this is the WAN side, right? One is
This
the
is,
MPLS,
yeah,
one is the MPLS router, and one is the internet router.
WAN C, yes.
Okay. Okay. Okay.
They're connecting here to the WAN side.
Mhm. And where this internet router is going to connect towards WAN?
Yeah, so this internet CE is connecting to internet PE. There also one router as a PE. Actually, behind the scene, everywhere BGP is running for this particular lab.
Right. Yeah.
I think I have configuration for all these devices.
Oh, really? Then it will be very helpful to
Yeah,
understand exactly. Yeah.
yeah, I have configuration for all these devices. Yes. Okay. You can have a look. If you have any problem understanding this, let me know. I will upload the configuration for all these devices. You can check.
Then you'll share
Sure,
the diagram
please.
also, right?
This slide, this PPT is already shared with you.
So that is inside PPT.
Yeah, you can see this
Huh?
one folder is there, CCNP, SD-WAN, something like that. There you have all this. Okay. All right. So let's
Can you
check
go back from this diagram? 1 minute.
diagram.
Yeah, the previous one. Yeah.
This one.
So in D, yes.
Mhm.
In DC1, there is a two VS devices is installed, and these two VS devices, one is for MPLS and one is for internet.
Yep.
And both is connecting to the hybrid, I think, huh? Both
Yes,
internet
hybrid.
and MPLS.
Both are going
Okay,
to both places.
connecting to
Yes.
both,
Yep.
both the transport link.
Yep.
And there is no connectivity between these two VS devices. And with these VS devices is independent to each other, right?
In this DCS, but they
Okay.
have common LAN segment.
Common line segment.
Yeah.
Okay. There is no T-lock extension here. Okay, got it.
For that we have one of the branch here in both.
Yes, because both is connecting to the two different transports, so not required for the T-lock extension. Yeah, got it. Okay, please go ahead.
Okay. All right. So I'll log into one of the data center device, that is TCVH1, and here you can see, let me go and restart. I think it's still out. Reconnect. Okay, font size is very small. Let me increase the font size. Party session. Okay, so in this DC1VH1, let's check the interfaces that we have. You can see that we have inside VPN 0, we have these two interfaces. Inside VPN 10, one interface. Inside VPN 20, one interface. So I'll go and create few interfaces. I can go to VPN 10, say interface loop back 10, and then I'll give IP address, say 10.10.10/24. No shutdown, although loopback interfaces are always up. I'll go to VPN 20, and inside VPN 20, I'll go and create one other loopback, say loopback 20, and then I'll assign one IP address, for example 20.20.20.20/24. No shutdown, commit and quit. Now since it is detached, so you can see here that configuration is done. Now you can check show interface description, and you can see that we have created a loopback inside VPN 10 and VPN 20. Those interfaces are up. Now if you want to check the routes inside VSmart, let's check in these routes inside VSmart first. So I can log into VSmart, and let me increase the font size. 18 is okay. We can see it properly. Okay. So inside this particular VSmart, if you go and check show OMP routes, first of all, I'll show you everything. Then you'll go and check the specific route. So we are interested to see 10.10.10.10 from where it is coming. This is system IP for one of the DC VH1. Actually, this is for DC VH1 10101, and you know that it is getting this route from DC1 VH1 twice. Why? Because one transport is MPLS, one is internet, as per the diagram, right? And then it is getting the same route from other VSmart as well. In this lab, we have two VSmart. One VSmart having IP 12.12.12.12, other having IP 22.22.22.22. Those are the system IPs. So clearly you can see that inside VPN 10, it is getting these one route via four different path, you can say, four different places. Likewise, you can go and check 20.20.20 as well. Same, because who is sending this route? 10.101 is sending. Why it is sending? Because if you go and check the OMP, so OMP, what OMP is doing, advertise connected. These loopbacks are nothing but your connected routes. So it is sending. So that's why VSmart is getting these routes. Now what VSmart will do, it will reflect the route to all the branches. So if you go to any of the branch, let me go and increase the font size here as well. So I am going to one of the branch, that is branch 1 CH1, and there will go and verify these routes inside different VPN. So here you can go and check. Here you have to use a keyword SD-WAN. OMP routes for VPN 10. Even I will show you more filter as well. Let's check from here first, and then we'll go and generate some filter. Where interested about 10, 10, 10. From where it is getting? It is getting from 12, 12, 12, one of the VS Smart. Two of the routes, I can see this is very important. So it is getting these routes, but it is installing those routes only from this particular VS Smart, right? Why? Because this is the primary VS Smart for this particular router, right? Likewise, if you go and check 20, and if you can see the
So then
filter,
that is primary. How will understand?
system IP is less.
No, but what parameter deciding that is primary?
System IP. This is 12, this is 22.
So is higher value. That's why that is showing as primary. Yeah? First one.
Yeah, lower value is primary, higher is secondary.
Here is the inverse, I think INB and U. Some routes is
Sorry,
INB and U in the in this
yeah,
section.
this is invalid, unresolved.
Invalid unresolved means this
Yeah,
is the self-generated IP, right?
yes. You can see 0, 0, 0. So 10, 3 belongs to same branch. So whenever it is getting from VS Smart, it is telling that uh, you can think like this. I am not trusting your route because it's self-generated route. So that's why I'm trusting on those routes.
Okay, so it will taking from this is a self-generated route 1030,
Yeah,
it's 10330.
yeah.
So CRR.
Show IP
Ratnesh,
interface brief. You can see that those are its own route. Sorry for that. Brief. See 10, 3, 13 somewhere you will see 10, 3, 10. What was that route? 10. Let's see. 10, 3, 10. 10, 3, 11.
Yeah,
10, 3, 13. So let's see where it is.
10, 11, 13.
10 is there, I can see. I'm not seeing maybe
11
11.
and 13 is not here.
Yeah. Okay. Let's see where it is. Display protocol. Where is my devices? Hmm. Just a second. I'll show you that it has some T-lock extension. Same branches having different routes. View and just a second. Let me check that how I can get my sessions. Yes. So if you go to branch 1 CH2, and I can see 3 show IP routes. From where these routes are coming? Let's see. 10. 13 redistributed, but this is also redistributed. There are some other simulation as well which is going on. These devices are also connected somewhere from where it is getting these routes. So that's good thing. We can inspect this. So for example, this particular route, let's see that who is the origin, how it is coming, all those details. Okay, let's see.
So
Show
I and B is the invalid, and U means you told me something.
unresolved.
Unresolved. What
Yeah.
is the meaning of unresolved?
Unresolved means it don't have a valid T-lock. That's the meaning of unresolved.
Okay, so
And
there is no transport path for this one, right?
Yeah.
Unresolved.
what is RAID you told last time?
Redistributed. You can see all those
RAID.
prefixes.
Okay, okay. No, forgot just. Okay, fine.
See, redistributed, then R is resolved, then unresolved stays, etc. Okay, so let's see. One of the route, show OMP routes, and suppose we want to check this one and in detail. 10.3.13.0, you'll see each and everything related to this particular route, from where it is coming, who is generating, how it is coming. So clearly you can see that originator is 10.3.0.1. It's telling that 10.3.0.1 is the T-lock, and OMP route entries VPN 10 route, this particular route. Peer is self, 00 means self. Uh, this particular device is generating this route. Origin protocol is static. It is generating by some static route. Maybe it is coming from some connected router where we have some static route from where it is learning. And since we have OMP advertised static, so from here it is going to VSmart. Okay, so this is self-generated route, means it is coming to this particular router via some static route. Okay, and then he is sending to VSmart, and then VSmart again sending back to him, and that's why it is not resolving this route, making this invalid. Okay, any other question to this?
Then it's going to go back to the vSmart line. I
Yeah,
want to show the
VSmart.
command one more time. I have on doubt.
Show MP routes for VPN 10,
Hmm.
and then you can see what was the route 10 3.13.0, right?
Not this one. You created loopback, right?
Yeah, that also I will show you. So VSmart is telling that this particular route entry is coming from this particular system IP, and originator is this particular system IP whose T-lock is this, and this protocol is static. It's coming via some static route configuration. Now let's go back to our routes that we have created. 10, 10, 10 and 20, 20, 20. So 10.10.10.0/24. Oops, sorry for that. 10.0/24 details. So it is coming from this particular edge device. And this is the T-lock. This is connected route and all those informations.
Not the detailed command. Initially, you're putting some normal command, right? It was
Yeah,
telling that.
simply remove this and VPN 10. And now you can see it is
Not this
giving
one.
you,
Like it was saying as a route.
yeah,
Routing table.
yeah,
No, table. Okay.
use in table format.
Oh. So, here is 20 to 20 is which IP? Like it's
Other VSmart. We have two VSmarts,
uh,
VSmart primary and VSmart secondary, like that you can think.
So one is coming via direct transport, another is coming via other benchmark. Is it correct?
Um, Let me draw here. You'll understand. No problem. So see that suppose if one of the branch having one route 1.0, and suppose two transports are there, and suppose there is one VS Mart, say VS1, I'll make two VS Mart and VS2. So what will happen that 1.0 will go here and 1.0 will go here via two transport. So he will know 1.0 is coming A and B. Suppose this is transport A and this is B. Likewise, this VS Smart will also learn 1.0 via A and B, right? Remember one very important thing here. We know that these VS Smarts also having OMP pair in between. So whatever
Yeah,
coming here, it will go here as well. Means they can also exchange the routes via OMP.
correct. Something else. Yeah.
So you can see here in any of the VS Smart that suppose if he is learning 1.0, so when he is learning 1.0, you will find that he is learning 1.0 from VH1 plus VS Smart 1. So if I go to the VS Smart and you will see there inside VS Smart that any of the route it is coming from here also. Okay, so not only that it is getting from the edge device, but it is getting from other VS Smart as well, and that's good. That's good because that is showing redundancy that you're syncing the routes from two different or three different control planes.
And it will not show it as a CIR, right? Because the install is showing in next tab.
Yeah, where you want to install the route in the edge devices. So in the edge devices, you can see installed.
But here it's CR and then the next tab it is showing install.
That is
What is the
good
meaning?
question. That is good question. I'll explain you this. See, one second. Let me scroll. You understand these prefixes like
Yeah,
chosen
yeah.
and resolved. Okay. Now, if you go and check show OMPPS, and you can see that VS Smart is not installing any route. Okay.
Mhm.
Because why he will install? He is not in the traffic path. He is the control plane. Either he is receiving or sending. Receiving, sending. Who will install these? His devices.
Correct.
So if you go to any of the edge device, let me quickly go to the CH here. And if you check the show OMP peers, so here you'll find that they are installing the routes as well. And I told you that since 12, 12, 12 is the primary, so you can see receive, installed, and send. But from uh, 20 to 2022, installed is 0. Now, in
Correct.
any case, if you go and reboot this VS Smart 1, you'll see that it will installing the routes, start installing the route from other VS Smart.
Yeah. Can you show another thing also, brothers? This is a good explanation. So when you're saying the OMP routes with the OMP command, the same whatever the loop you created, right? With the help of tlock command also, we'll be able to see, right? In the edge device. So tlock some
T-lock,
command will be there, right?
T-lock is different thing, right? T-lock is nothing but your next hop. So you can go and check. See, so SD-WAN, OMP T-locks. You can check this. There is no problem, but It will tell you only about the T-locks, whatever next hops are there. OMP
After
routes,
T-log, you put question mark. There is another command after T-log.
T-locks and T-lock paths are there. Two options are there.
After T-logs, put question mark.
Okay.
Okay, it doesn't. Yeah, is there a command show SD-WAN T-log without OMP? No. Okay. Any receive route? There is command. Any receive route related?
In OMP, yes, you have that. So if you go to show OMP and yes, you have to give the prefix. So let's go to routes and say 10, 10, 10. Those things are there in BGP, right? Detail is there, family is there. We don't have any, means we have only IPv4 address family. Okay, VPN, I don't think so it is there, but let's check. Only detail option is there. Options are not there.
Okay. Right.
All right, great. So this was one of the small lab that we have done. Let's quickly go back to the slide and let's see what other things we have inside our slide.
Yeah, one thing, Ratnesh.
Hmm.
Scroll down to the up screen. This one, same page, same page. There is the two V Smart is connecting back to back is peering, and one is showing the installed and one is showing the zero installed now.
Okay.
Go back.
Show MP peers.
Yes, yes, yes. Here it is showing the install is the 44, and here it is showing the zero, right?
Yep.
So this is the secondary V Smart, right?
Yes.
So he was saying that the V Smart is not installing the route, is it?
This is not BS Smart, right? This is CH.
Yes, yes. But here it is showing that the peer IP 12.12.12. What is the IP for this? This is the V Smart IP, right?
Yes.
And this 12.12 is forming the peering to the 22, and this 12 V Smart is having the 44 installed route. Am I right?
This detail is related to this particular CH. CH is installing these 44 routes.
Okay, okay. I thought that it is showing that the V is not installed route.
No, no, it's not. It's,
Okay,
it's
whatever the
related to
information
this.
it is showing that it is related to the edge devices.
Yes, and see this 44 you're seeing here. If you go and check show MP routes, where you are seeing I, if you go and check those I entries, you'll find those are 44.
Yeah, okay.
All right, good, good questions. Okay, let's continue and let's see. A few other topics are there inside OMP. So you can advertise, even we have the option to redistribute as well. I'll show you this redistribute in upcoming section when we'll go and learn about the control policies. There are some notes as well. Please go refer these slides. Um, a WAN edge router, a WAN edge router can have up to 6 WAN interfaces, and each WAN interface has different TLOC. Obviously, different interfaces having different TLOCs.
But
And
one WAN devices is having the limitation up to T 8 T-lock we can
no,
configure, right?
TLOC is different thing, and edge device can have up to 6. This is for edge device, not we are talking about TLOC.
No, no, but T-lock means that is the tunnel endpoint of the WAN connection where it is going to connect to the transport. So suppose that if one VS device is having the 6 WAN port, then how we can create the 8 T-lock in that 6 WAN port?
We can't create.
Yeah, then but theory is saying that we can create up to the 8 T-lock in the one box. That is the limitation. So is there any specific box we can create 8 T-locks, or each box we can create a 8 log. Suppose that we are using the VH1K, in which there is a limitations, or maybe there is some, I think it is supporting the upstream link is the 1
Yeah,
Gbps.
your question is right. So maybe you heard about that we can go and create 65,000 VPN, right?
Correct.
But practically, can we create 65,000 VPN?
VPN, I think there is some limitations. I think VPN 0 and VPN 512. In between, whatever the VPN is coming, that is for the service side VPN, means 1 to 511, right?
Yeah,
Maximum.
but this is for V-Edge devices. If you go and check for
Correct.
C-Edge,
Correct.
you can create up to 65,000 segments. But even we don't need 65,000 segments. But yeah, theoretically, you can go and create 65,000, but no one is creating that much. Even in production, also, you'll find 4 to 5 VPNs. More than that, you're not seeing that. Um, this point that you are seeing here, that a V-Edge router can have up to 6 WAN interfaces.
Mhm.
So these are the physical interfaces, right? But
Correct.
but we can have some other virtual interfaces as well, like sub interfaces and all, where also you can go and create some more T-log.
Okay, so including the virtual interface, we can maximum create the 8 log. That is the point, or
Yeah.
maybe I'm wrong.
I think more than 8 T-log also we can create. I need to check the document. Maybe 16 T-logs we can create.
Okay, as of now, I know it that one box is supporting maximum up to 8 log, but I don't know how to create the 8 log, because suppose that if we have the 4 WAN port, then definitely the 4 WAN port means the 4 log.
Yeah. So please do some, Google that one particular box, how many T-logs we can create. I think 16 or maybe more than 16 we can create. Okay. We know that and you also know this thing, that suppose if you have 1 gig interface, say 0/1, here we can create so many sub interfaces, right? And in those sub interfaces also we can go and create some T-logs. One example we have, and we will see this in upcoming section, is T-log extension. Suppose
So
if we
is
have
there
one.
any limitations for creating the sub interface in the one physical interface? Yeah, because if you are
you know
talking the 16, 20, whatever,
I'll
so is
tell
there
you
any
this
limitation?
thing. See, the answer is this, that there is always limitation, there is always practical value and theoretical value, and all your questions are valid, but you can do little bit, maybe it is coming on top of your mind, you're asking to me, but I don't have answer for this question, that how many sub interfaces we can create. I think we can create crores of sub interfaces in one physical interface. How means, if you go and check, let me quickly show you this. So if you go here and check, I have to move to config transaction. Oh, we are inside that. So if I go to interface, let me see if I have any gig interface or something. This is very basic question, Lisp is there and all those things are there. So what I'm telling, you can check in any GNS routers, is gig 0/1 dot. If you type question mark, you will see here option, maybe 1 crore, 2 crore, something like that, 10 million or something. That many sub interfaces we can create in Cisco routers. There is no limit actually. How many sub interfaces we can create, but again, how much sub interfaces they will support, that's the thing.
Okay,
Okay.
okay, got it. Okay.
All right. We have discussed about the hold down timer and other timers. That is good. And then redistribution. Obviously, I will cover redistribution in upcoming section, but you can redistribute a static OSPF, BGP, all those things. And some of the AD values are there just for your reference. Okay, so
Ratnesh,
please.
can you go
Mhm.
back to the previous slide, the redistribution slide? It is telling first line, OMP automatically redistributes the following types of route that is learned either locally. Uh, so automatically advertise, huh?
Yeah,
Nothing we are
so
doing.
not everything, these routes. Suppose you
Yeah.
have OSPF EIGRP. I told you that there is one configuration by default, OMP advertise, right? So that means from service side VPN, you are sending those routes to VSmart. So this is one way redistribution. Suppose the OMP routes, if you want to send to OSPF or EIGRP, so that will be the mutual redistribution. These parts we'll see later on, but this configuration is there. Let me quickly show you this. So if you go here and go to that device, and sure, an OMP will work. Here you can see OMP is there. So advertise connected and static is there by default.
So this is automatically coming within the convention.
Yeah,
Nothing.
that was default configuration. So suppose we are pushing some template. In that template, those defaults are by means it was there by default.
So in OSPF is there automatically it will advertise here, huh?
It is not
Command.
mentioned here,
Uh,
unfortunately. So that means no.
we have to do it, huh? Right?
Yeah. Yes. You have to do it. Yes.
And
Okay.
for BGP, we need to do it manually redistribution, right?
Yeah. For BGP, because this is again one type of overlay protocol. So you have to do it manually. Means options are there to do all this redistribution. Whenever required, we can go and we can do it.
When you open, show me the opposite side redistribution. When you open that command prompt.
So here you can go to say VPN 10 and router OSPF area 10. I'm just giving you one example, right? And here you can go and add interface as well. So we have created one loop back 10, and then you can do redistribute. So let's see, should have redistribute command. I can see that necessary in this tab. Okay, just hold on. So redistribute and OMP. I can see OMP, and you can enter or you can use route policy as well. With some policy, enter, commit and quit, show run VPN 10. So inside VPN 10, we are going to OSPF, and inside OSPF, we are redistributing OMP.
Okay. And inside OMP, you are distributing advertising OSPF.
Yeah,
Okay. Thank
great. Although I will cover this in later section, this way of redistribution, we'll see that. All right. So next topic is also very important, and more towards theoretical and more towards that in the interview they will ask you that um, how it is happening, why it is happening, etc. And one of the question that Sanjay has asked me, that also I will cover, but not today, maybe in upcoming class. We are reaching to that particular point where he has asked that thing. So let's go and check the part number 2 for today's session is the PNP or ZTP or device provisioning. What type of methods we have when we are onboarding the device. Okay, and these slides will help you to understand all those theory, everything behind the scene. So first of all, I will go and cover ZTP. Okay, let me see if I have some other slide now. Okay, so first of all, I'll go and cover ZTP, their theory, their lab, and then I will go and explain you about onboarding. Or we can do other approach that let's check few of the slides, theoretical slides first, and then I will perform the lab task. Okay, so let's see few of the theoretical slides. For example, this slide. This is one of the summary slide taken somewhere from Cisco document deployment guide. You can see WAN is onboarding steps, how it is happening. So WAN devices, they are authenticating with vBond, right? Then vBond is telling the IP address of vSmart and the other controllers. So step number 2, that they are authenticating with vManage vSmart 2 and 3. And then they are part of, means they will bring up the control plane and data plane. So then they have the BFT session up and running. Like this is happening behind the scene, we know this thing. But there are some other things as well that I want to clarify. Let's see that. Then I'll come to this slide. And then Sanjay has asked me that over MPLS how we can reach to vBond. I will come to that later on, maybe in coming classes. This is one of the slide that you should bookmark. This is one of the nice slide we have related to understanding the deployment of vEdge and cEdge. So here you can see that if you have iOS XC SD-WAN, if you are doing some automated deployment, so for that we are doing PNP, plug and play. For vEdge devices, we are doing something called ZTP provisioning, zero touch deployment for automated deployment. Okay. Now, if you are doing some sort of migration, you can create bootstrap configuration for iOS XC SD-WAN devices. And for manual means you are doing line by line by line by line. So you can do that manual configuration for vEdge, you can do for cEdge as well. Okay, so one slide you can see, but different aspects are there. You are doing some automation for deployment. So this portion is for this automation. You have option for manual or bootstrap configuration as well, so that you can do for cEdge and vEdge what are the differences you have. You can clearly see from here, right? And not only this, but you'll find some chart as well. So which of the device they are supporting plug and play, bootstrap, manual, ISR 4K they are supporting all, 1K supporting all. The platforms they are supporting ZTP, VeloCloud they have some sort of manual configuration. Okay, so just for your reference that which device is supporting what.
So suppose that if we are going to deploy the ASR series router,
Mhm.
VH means this CH router. So we need to only put that serial number and chassis number in this plug and PNP portal, right?
Yeah. So
But
how it
here,
is?
actually in the production environment, I'm doing the RMA of these VS devices. So what I'm doing in day by day here, we are simply going to the login into the PNP portal because
I'll
I have
come
the
to
access
that
of the
point.
PNP.
Just hold on. I'll come to that.
Yeah, actually, I just wanted to know about the difference exactly.
Okay, now you can come. So you're logging to PNP portal, right? So we are inside PNP portal and inside your virtual account. Then how it is happening, you can see here in the slide. So you have your smart account. So any network engineer, They can log into the PNP portal with a smart account. A smart account may be tied with the smart account virtual account. You are inside the PNP portal. Inside that PNP portal, you have your listed devices. You have your controller profile. Controller profile in that case is nothing but the VBond profile. Okay. So now um, this can be right? Synced with the vManage. In vManage, you have option that those serial number chassis ID will be synced, right? Now, once they synced, then they can go for PNP. Now, you tell me what you're telling.
Actually, what is we are doing? Yeah, the same process we are doing here, the PNP, and then we are going to log in into the vSmart account. Sorry, and this vManage. And from the vManage, again, there is the option where you are going to the device, and there is the option for the configuration. In the configuration page, there is the option for the sync this smart account. So we are also using that Cisco ID for the smart account, and whatever the information means we are putting in the this PNP server, PNP portal, that is the serial number and the chassis number of the edge devices. That information is syncing with the vManage. So it is pulling the data from the this PNP and inform to the vManage, and vManage is informing to the vBond and the vSmart devices. This is the new box, and we are adding the this serial number and chassis number, so that when this VS devices is going to connect to the internet, it will authenticate by the vBond, because vBond know about that serial number and the chassis number.
See here,
Yes,
sync the smart account option is there.
right, right. So after putting the serial number and chassis number in the PNP portal, we are simply logging into the vManage, and the vManage, we are going to the device and configuration, and click on this sync smart account. It is asking the Cisco ID. I have the Cisco ID. I simply putting my credential, and it is going to sync up that PNP. So my question is here, means the same process we are doing for the this CS devices and the VS devices, because you are saying that the automation means deployment. For the
Same
VAs, we are
process, yeah,
going to,
same process we are doing.
yes, because each and every day we are doing the same process. Then what is the difference for the this CH? Because you were saying that the CH is follow the PNP and the VH is follow the this GTP. GTP means it is going to the manual. So what is the manual and what is the automation? Means we simply putting the chassis number and serial number in this PNP for the CH if the branch is deploying with the this CS devices, and we simply going to log in into the PNP portal and putting the chassis number and serial number. So it will automatically reconfigure that branch devices for the CH.
Yeah. So difference, you just forget about SD-WAN. Suppose you have one router. That
Mhm.
router you can log in via CLI, and you can put the command. You copy means you type everything in Notepad, copy from there, and put inside the router via CLI. So that is called manual way of configuring a device. Automation means that you have some Python script, you are running it, and automatically it will get configured. Likewise, to configure a device, you have two options. You can do via the PNP ZTP, that is automation, or you can do it via login in, and then line by line, you're configuring it. The key point here is this, that as long as these devices have five important configuration item, right? What was it? System IP something, site ID, vbond, org name, and host name, right? So if you go and put these five important configuration, then only it will go and connect with the controllers, and then they will be part of the fabric. Once they are part of fabric, again with the CLI you can go and put the rest of the configurations. It's like manually you are doing. Or once they become part of your fabric, then you are pushing some sort of template to this particular device. So from template they are getting the configuration. Now in case of PNP ZTP, even the template also will get pushed, the image will also get upgraded, everything will happen behind the scene on behalf of ourselves via some sort of automation. So that's the difference. Via script, manually, line by line. That's the manual.
Okay, so that is for the initial level of setup, right? And
No,
suppose
is
that if
no,
Mhm.
not initial level. See, big organization, why they will configure their devices manually, right?
No,
They
no,
will not.
because each and
Mhm.
everything we are going to create, suppose that we are going for replacement of the one devices and everything is already populated for the existing old devices. Okay, it is creating the features template and device template, everything is there. So simply we are going to connect that VS devices or CS devices into the internet, and we are follow the same process PNP, and then automatically we are configuring this file line, means bootstrap configuration, and it is going to connect to the VWAN and coming to the SD-WAN fabric. So suppose that if we are the new branch and we are going to create the template, so this if we are going to create this 5 line, so once this CS devices is connecting to the this VWAN, and we want authenticate that CS devices, it will tell us that this is your vSmart and this is your vManage. So now after that, this DTLS tunnel is forming to the this vSmart, and this there is no role of the VWAN. It will be disconnected, right? And after that, whatever the configuration means, the device and features templates we have configured here in the vManage, it will automatically sync up, right? Or we need to do it manually, because the ACE devices is already came in the SD-WAN fabric.
Okay. So your question is that the template will automatically push to the device
No, no,
or
means
not?
we need to attach it. There is the option for the device attachment.
Mm-hmm.
Attached to device means there is the option attached to device, and then there is the corner button, the send to the controller option. There is the option there. So after that, all the template is going to send to the this edge devices, and after that it will working like as a normal device, means in the production scenario we can work it.
Okay. So everything you are telling is 100% right, except one thing is this, that when you are pushing the template, those templates are variable based, right? So you need to update some sort of CSV file as well inside this.
Correct, correct.
Okay.
We're going to upload it and
Because
download it. Yeah,
yeah, different yeah, upload, download, or
yeah.
simply if it is a generic template, means device feature template or device template, you can simply upload it. Otherwise, how different edge devices, they may have different WAN IP, right? They may have different type of configuration, etc., etc. We have discussed this long back in our template section, that different branches you can identify, and different branches, they may have different styles of device configuration template or device template, right? So
Correct, correct.
yeah, so
So
those
here,
things, as yeah, those
yeah,
things
yeah.
we can't automate because it's actually very difficult to automate. And that's why long back we have discussion about this PNP, plug and play, that this is plug and play feature. This is not 100% automation itself, because 100% automation means that you are not touching anything. You connect the device and it will, come into the production, but still you have to do some touch points. So this is uh, plug and play. This is not plug and deployment or something. This is ZTP, zero touch provisioning, but this is not zero touch deployment. So ZTP is not zero touch deployment, ZTD. But some of the SD-WAN, they are offering zero touch deployment as well. Okay.
Only plug and play.
Yeah, means 100% simply, yeah, only plug and play. You're right. Yeah. You plug it and it will come online. Yeah.
So for the any devices, whatever, maybe it is a CS or VH, we
Mhm.
need to do it the same process PNP, and then it is going to connect to the GTP. Actually, in the theory portion, it is creating the confusion. If you are going back to the slide, it is mentioned that the what is the difference between the GTP and what is the between this GTP and the PNP. So
So
that actually I
ZTP,
understand.
you understand? Right. So ZTP actually for edge devices, initially Viptela came with ZTP. And plug and play, we are telling that from plug and play portal, you are syncing the serial number and all those things. So that is for CES devices.
So after PNP, again, it is going to send that information to the GTP server, right? Suppose that
I
here
mean,
in the diagram, here we
in the
mention the
diagram, it
VH.
is, yeah, in the diagram, it is showing if you have different servers, then, yeah. So PNP portal is different and ZTP portal itself is different. So from PNP, it is uploading ztp.viptela.com or ztp.cisco.com. Here, PNP is like software.cisco.com and then pnp.cisco. Whatever, means only this cloud hosted servers, they are updating their database. That's it.
Okay, so here in the instead of the VH, if we are putting the CH, it will follow the same process, right?
Yeah. Yeah. Right.
Okay.
I think Ramesh, the VA you're putting VAs here is all using PNP portal.
Yeah, because initially these VH, their controllers are at ZTP servers. So here you can see that PNP Cloud Service, Cisco, they are uploading everything to ZTP. But don't worry, nowadays, in new deployment, you will not see VH devices. So this portion Cisco is removing. I think this is 2 to 3 year old slide. You will not see nowadays this part in the new deployments. Simply from here, that's it, to the
Yes,
CS.
yes, yeah. Currently we are doing, but actually in the theory portion, if someone is asking the question how GTP is working, then we can explain like that.
Yeah.
This is a zero touch provisioning, but actually in the picture it is not coming because I am doing this RMM replacement of the VS devices and we are using the PNP. Correct.
Great. So let's understand that how this GTP is happening. Okay. And just for your interviews, sake of interview and plus one small lab, I'm going to show you that. This is one of the slides. You don't need this theory to understand and this and all these things. If you understand this particular slide itself, you will understand all those theory. So you can see that I want to onboard one of the device, that is one of the VH devices, specifically VH device that will go and join the fabric. So step number one, that plug on that device, right? Then somehow it will go and get the IP address and it will go and get the DNS resolution that how he can go and reach to the ZTP server. What's the IP address for that particular WAN facing interface? So it should go and get step number 2 and 3, IP address and DNS resolutions. Now, once it has the information that how he can go and reach to the ZTP server, here you can see ZTP server, something like ztp.viptela. Initially, it was like that, viptela.com. So there it can go and reach to that particular server. Now, you know that all these PNP servers, they know about this organization name, they know about that client info. So they have the information about the client, they have the information about the local VPN or the client VPN. So once you go and reach your GTP server, they will go and redirect you, that means the edge device, towards the local VPN or the organization VPN, right? Now VPN, what it will check? Serial number, chassis ID, right? And edge devices, they will go and check the organization name of the VPN. Now vBond will offer the vManage and vSmart IP address. So now they are doing the authentication with vManage and vSmart. Once it is get authenticated, again it will go and authenticate with vBond. Again it will go and authenticate. It's not authenticate, but step number 8, you will see that we are pushing the template or images to the edge devices. Once you push the images, once you push the template, actually image and then template. So once you push the image, then this device will get rebooted. Once it will come back online with the latest image, then again it will go and communicate with vBond. Because whenever any device will come into the picture, it will go and contact with the vBond. And now at this point of time, he has the information of the vmanage, vsmart, we want everything. Again, it will go and re-authenticate with vsmart. Everything is good and okay. It will go and join the fabric. Okay, so this is the ZTP process you have. I
So after
already,
complete the configuration, it will the device will be reboot, right?
yes,
And
it will get rebooted, yes.
it will get reboot, and once it is coming up,
Whenever
and
it
then
will
it
come
is
first time, it will authenticate with V1.
V1, and then after that the connection will be disconnected from the V1, and then it
Yeah,
will directly connect to the VSpot.
100% right. Yeah.
So Ratnesh,
Hmm.
first time when the new device contacting V1, so that time those exchanges are happening, right? Serial number, serial number, and all that.
Yes, yes,
When
yeah.
after the reboot, again it is contacting, again it is going through the same process, or it's a quick process.
Same process, no quick process, same.
Okay.
And the explanatory slides are here. You can have a look on that. But whatever I have explained you, it is written here. Just I have just copy and pasted from Biptela website. All right.
That means I have the one small question here.
Mm-hmm.
Suppose that in case of any production issue and we are needed to the power recycle the VS devices, okay, it is working fine, but due to the some reason maintenance activities, we are going to power recycle the existing VS devices that is already running and working fine. So in that point, suppose that we are just switch off and switch on the device, again it will going and contact to the vBond, because vBond
Yes.
is the initial point of authentication, right?
Yep.
So
100%.
each and every time, once we are going to reboot the VS devices, first it will going to contact to the vBond. vBond is authenticate the VS devices, and later it is going to connect to the SD-WAN fabric, right?
Yes. 100% right. Yep.
Okay, okay, got it. Got it.
All right. Great. Okay. So I am uploading this recording whenever we have class, maybe after 1 day or 2 day to YouTube. I got one question in YouTube that can you give me commands related to OMP debug? Please remind me this. Just now I recalled that question. Please remind me this that I can show you some debug commands related to OMP in the upcoming session. Or whatever we are doing, can we check all those information in debug as well? So say if I am telling that once you reboot, then it will go and join the vbond or contact the vbond. Can we see it in the debug? Yes, we can see it. Let's try to check that also. Okay, so I'm going to show you the lab related to ZTP server, and that is simulated inside the lab environment, but it will give you all those steps. So let's check that, and I will enable the debug as well. Okay, I'll go and enable the debug and then perform the lab. So I can go to branch to vh1, and what's the command to enable the debug? Debug transport events. I'll leave that label. Any other thing we have? Let's see. Yeah, the debug. Although the font size is very small, what I have done, I simply run one command, debug transport events. I should increase the font size. Again, once it will reboot it, see that the size will get decreased. Okay, no problem. I'll increase the size one more time. Let me go here and okay, apply. Okay, see what debug options we have here. So debug BGP, CFlow, OMP is there, right? At the moment, I'm not debugging OMP, but debug option is there with OMP.
So is it good to use the debug command in the production environment?
No, never.
Yes, because it is creating a lot of packets and it's stuck the CPU utilization.
Yeah.
So
So
for what a purpose we can use it here? This is for
just
the
to
initial deployment.
see the packets. That's all.
During troubleshooting, we should do this.
Only
No,
troubleshooting.
no, no, no. Only
Only
troubleshooting,
troubleshooting
but
means you already know that what is happening behind the scenes. So why you need all these logs? right?
No, I understand, but the debug is strictly provided in the production environment.
Yes.
We are not going to use any debug command in the
Yeah.
troubleshooting as well.
No, we can use
Troubleshooting you can
two tools.
use with some filters, you know.
We can
Actually,
use
I just wanted to understand about the TCP dump. Suppose that if you want to capture the packets, so we are using in the production environment for capturing the packet is the TCP dump. There is the one command we are using, but we need to understand the packet reading as well by using the this WireShark. So there is another technique we need to use it. So if you can cover the WireShark technology, it will be good for us.
yeah, both the things, whatever is required, we can use. But
Yeah,
only
yeah,
if there is
because
an issue. Otherwise, it may bring down.
yeah. No, no, WireShark is good. Means if you are capturing the packet and that packet is we want to open in the WireShark tool, we
Hmm.
can read it exactly. But how we can read in the WireShark? That is the main question because the customer is having that I am sending this packet and it is not going to the my application, so there is the problem. So in that case, we are capturing the packet for the troubleshooting parts, but we are not able to understand where the packet is. There is the UDP packet, TCP packet. I have the tools. I open that packet but it is showing that this is the port, this is the destination port, but how it is going to stuck, that part we are
Yeah.
not able
So,
to
you know,
explain it.
for visualization sake, you can integrate SD-WAN with different tools, and one of the TCP generated tools. What is that tool name is? Um, what tools you are using for
Uh,
visualization?
I think in the solar winds as well, na? In the that is for the
Solar wind
monitoring,
is
right?
not
Solar
there.
winds and these wires are.
Wireshark is different. Okay. There are different tools that we can integrate our SD-WAN. One is commonly used, that thousand eye. You can install thousand eyes agents inside the SD-WAN ISR routers. And since Cisco, I think Cisco has acquired that company, so they are pushing their customer to, use thousand eyes. And other tool is that was used inside Cisco IWAN. Cisco IWAN, that tool, I'm just forgetting the name of the tool. Um, okay, I will recall it and I'll tell you. Means some tools are there where you can go and check exactly what is happening at what particular WAN interface. Now, when it is coming to do local type of troubleshooting, then you can use Wireshark. There's no problem, and different filters inside Wireshark you can use. Means hop by hop you can check, take this sniff, and then you can check
Yes, that is
going
a
and
very
return packet.
good tool.
Now it
This is for
means
the
good tool.
normally it
How
means
means how we are telling good tool means you can't use Wireshark in a day. No, this is some sort of offline tool, and if you have thousand eyes or other things, means thousand eye, that they are checking all the, you know it's a robust thing. Thousand eye, it will tell you everything about everything, whatever happening in the path and different paths and
how the
BGP
packet
and
is traveling from one hop
yeah,
to the
yeah,
another
yeah,
hop.
yeah, 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 yeah.
So it will work in the only internet or offline that you are saying.
Offline also, because it's installed as a agent.
Mm-hmm. So
Yeah.
there is no internet connection is required to connect to the any
No,
server
it
to
will
check
it
it.
will work on any transport, only internet. Everywhere it will work.
Okay,
Anyways.
okay. So that is the paid
See,
tool or it is a free, we can download it from the Google, like Wireshark.
It's a paid enterprise tool. Cisco has acquired that company. They have paid lots of money. Yeah, yeah.
Okay, okay.
yeah, that's a paid to right. Rather hard the tool name, but this tool automatically capture like traffic or like
Everything.
we need
Yes,
to.
yes.
Oh,
It
it's a,
is
like
capturing.
on
It's
real time
one of,
monitoring capturing. Yeah,
yes, yes, yes.
no need to put inside any dump or something like that.
No need. Yes, it is one of the tool all the enterprises are using at the moment.
Yeah,
Most of the
because the customer
enterprises.
is coming lot of question. They are coming to us with my application is not working. We are getting a lot of latency in my application. So
Yeah.
our mind is stuck totally in that time.
These
Where
things.
from which
Yeah.
point we need to start the troubleshooting.
These things you can easily explain with thousand eye, and there are so many automations. It's a full automation type of tool. One of the
So,
tool which is supporting all sort of automations and scripts.
this will work only for the Cisco vendor or the VeloCloud as well.
This was open tool. Now Cisco has acquired that company, so I think it's open.
This is open standard tool, means it will support the multi-vendor.
Yes.
But, but the
And that
question
is very
is, if
good
the
invention.
customer doesn't have that, you can't tell customer you have to purchase this tool. Then only I can tell you what is the problem. What is the other
Otherwise,
solution?
customer will start the self troubleshooting.
Yes.
They will not come to us and they are not asking anything. Yeah, there is a packet drop here. This point we need to check it.
Yeah. So I just wanted to see that where these packets will go and store this daemons, transport events and all. So let me quickly check where it is. So you can go to var, and I think inside temporary folder it should be there, or maybe inside retailer folder. Let's check one by one. So temporary, and then let's see what options we have anything here or not. Let's see, it's not there. Okay, let's go to ups retailer. Log is also there. I'll check the log as well. Okay, and
Maybe crash.
crash. Okay, this log is there. Yeah, so it is there in the var and log. This directory. Okay. Um, Let me go and do this ZTP process, and then
Where
I
you are
will
seeing
go.
that file?
Yeah, you can go
Where
to
you are seeing that
shell.
file? No, no, in this table, in this table. I understand that part.
Okay,
Here, where you are seeing that file? What generator?
I will show you that. So go to log and do ls. Okay, and vdebugs, they will show you the date as well. You know, so you can see vsyslog is showing you syslog messages, and it should be there in the debug, right? So oops, this is not a v debug. I will go and check the debug folder. It's showing very old, 7th of January. So you can check ls minus la, and in this folder you can see all the logs are there. We'll go and check that. Okay, no worries. We'll check. Let's go and do the ZTP deployment. Step is very easy. You can go to the configuration. In this particular lab scenario, it's easy. You can go to the configuration and devices. So one of the edge device, VeloCloud, you can go and attach. I should go to template, right? So you can go to configuration and templates, and you can see branch type to attach the device. This is the chassis ID, attach it. Now next we want to upload the CSV file. So one CSV file with all the variables are already there. So I can go to desktop, it is there in the desktop, and type to branch type, yeah, this one I think, yeah. Upload it.
So you downloaded it previously, or how did you get that template?
It is there in the lab pod. You can go and use it. All the variables are there. So it is in progress. First of all, this check will show you green signal, and then you can see this here as well. Now what will happen that the name of this edge device will get changed. Once we have the full deployment, it will show you something branch to VH1.
Hmm. One thing I'm not getting, Ratna, is like, what is the relation with this template attachment with this GTP? GTP means you are putting a new device, right?
Yeah,
Automatically.
new device automatically we are putting. Yes. So we are following the ZTP process. Whatever process is there. So this device, first of all, this device will boot up. One second, let me show you the diagram. So what will happen here is this, that one device is there that is not attached with the controller. It is there and we can log into that device with some management IP. So I logged in by the management IP. I have done some debug commands in that. Now what we are doing, that next phase is this, that we are discovering this device inside vmanage, and then we are pushing the template to this device. And with that template, you will see that it will get the configuration. Then it will go and authenticate with vbond, vsmart, vmanage, and it will become part of the fabric. That's the whole thing we are doing with this particular branch to VH1 device. Okay, and rest of the process is the same that is there in the slide related to ZTP. So let's go here, and if it is done, then you will see that it will change its host name and it will become a vmanaged mode. Meanwhile, let's see if any debug log is something is coming here. Let's see what's the date today. We should have some log related to this date. Let me exit. Let's say show clock. What's time this device has? 3rd of September. Okay. So now we can go to this shell var log.
I think there is the one more step we have to do it here. After pushing the template, we need to
Mhm.
go to the certificate and we need to validate the device. And after validate, there is the option to the send to the controller.
Yeah, means in I told you that this is simulated lab environment. Everything is there in that. So don't worry about certificate. In this particular lab only. Um, Still, it is not coming up. I know that in this lab, this particular simulated lab, you need to do one more thing here, that you have to go to the dashboard. Inside dashboard, you'll see that there is one in Python script, tunnel bring up. You have to double click on that. It will go and bring up the circuit. I just double click that and you'll see that it will come. That
Where is
means
this option, the channel bring up?
it's bottom. You can see here, tunnel bring up.
Dashboard.
Yep,
No, no,
I know.
here it is, but in the Cisco dashboard, we manage dashboard, here is the option.
It is not in the dashboard. Means you should have a reachability between the device and the vBond, right?
Mhm.
So if you do this script again, this is simulated lab environment.
Okay,
You
this is a
you need
different tool, right?
this is Python script.
There is a Python script.
Yeah,
Okay, okay. That is separate to the this dashboard.
yeah, that is
Okay.
separate. Yes,
Okay, I thought that it is included
this
in the
is
the managed
this is
dashboard.
bringing up. You can see command like config gig interface no shutdown exits. So bringing up the interface in this.
Parallelly, we can run this tool and we can see what is the step it is following, right?
Sorry, come again. Parallelly.
Means once we click on this tool, tool, so it will show it that what is the steps it is going to take the this device into the SD-WAN fabric.
Yeah, simply we are bringing up that gig interface so it can contact to vmon. So that's the whole idea. And then behind the scene, that bring up process is going on. Once it is up and running, you'll
That
see
is
that.
for which tunnel? That is for which tunnel? Creates the tunnel formation with the VMon.
Hence reachability, and this script is there. Let me show you this script. So there is one script. What this script is telling, and again this is just for this lab. So what this script is telling, that bring up the gig interface to, this is facing towards the internet. Bring up the tunnel. Okay, some emulation is there. WAN emulation tool is there in this lab. Just bring up that interface. Okay. And let's see if it is doing something. It will take some time, maybe 4 to 5 minutes to come back this particular device up. Meanwhile, let's see 3rd of September if I have any syslog. See, I have this syslog. So can I go and check this syslog message? What is happening behind the scene? Let's see. In this syslog, you'll see that lookup failed is try to contact with vbond.cisco.com. Let me pause the screen.
So
So
this is
DNS,
February 28th message.
yeah, sorry.
This is a February 20th message,
This is Feb
not
28.
recent.
Okay, it is going down. We have um, we have log for 3rd September as well. So it will go to that. Just give some time, or we can do one thing. We can cancel this. I can't cancel this. We can check bottom 10 lines or bottom 20 lines as well. But in this also you can see that it is telling that it's tried to contact with the vbond in all the fail messages. I'll go and I'll open one more session so I can show you only bottom line. It's not allowing me to open other session, but I can open in the of September. You can see we are in this September 3rd. What is happening here also is failure is there. Why? Because if tunnel is not up, that means you are not able to contact to vbond. So it will show you all these fail messages. And do we have anything? Oh, seems something is happening. Great. So luckily we have issue resolved here in the syslog message. You can see whatever happening behind the scene, it is showing you all those information. And if I scroll a little bit up, and there's so many nice informations we have here. So first of all, it was trying to resolve the DNS. So you can see this DNS failure. Now if I scroll a little down, DNS failure, let's see when it resolve the DNS. At the moment, failure, here. Somewhere here, you will see DNS got resolved. See, now it is reachable via path gigi00. vbond.cisco.com is nothing but the vbond IP. And then vbond is offering vmanage and vsmart IP addresses to this particular device. So it can go, and parallelly we have pushed the template as well. So vmanage peer IP, vmanage system IP is 10.10.10.10. This IP Now this edge device know this IP, and then he is able to reach to vmanage and able to authenticate to vmanage. Then vmanage is pushing the template to this particular device. Once it is pushing the template, inside that template it is giving all the information like system IP, the VPN IP addresses, everything inside that template it is pushing. So all this push is going on behind the scene. It's going on now. You can see that it is initiating the OMP peer with both the VS smarts. So OMP peer get started means still it is bringing up the control connection. So till here you can see it bring up the control connection, the DTLS and OMP, and then it has initiated the BFT session, right? Initiated the BFT session with all the other branches, and then you can see all this JSON format configuration style is there. Now the OSPF also in this branch, I think one router is connected in some VPN. We'll see that later on. So its OSPF is also run. So you can see the order. First of all, it is bringing up the control plane. Then it is bringing up the data plane. Then it is bringing up the service VPNs. So service side VPNs are coming up. Everything is up at this point of time. Now, if you go and click enter, you can see it has changed the host name, right? And now, if you go to the dashboard, you'll see that this device is working as a vmanage mode. So you can go ahead to the configuration and devices, and this branch 2 vh1 is vmanaged. Okay, so this is the ZTP process. This was also important topic that we should know. I'm going to pause the recording. If you have any question, you can ask.